Bernoulli trials, type 2, finding an unknown. So this is a nice question here where we are asked to find out how many times we must flip a fair coin in order to ensure that there's at least a 99% chance of getting at least one tail. So essentially what we're looking for is how many times. So for this, we don't actually know what our number of trials are. So we're trying to find n in this case. We're looking at a fair coin. So fair coin means it is equally likely chance that we're going to get a head or a tail. So that means that getting a head is going to be a half, and getting a tail is also going to be a half. So it's fair that they're both going to be equally likely to be got. Now we're looking here at two things, right? We want to get at least 99% and at least one tail. So that's going to be important in the setup of our question. So the fact that we're looking for at least one tail means that it's going to be easier to do this question if we do like we did in the last two examples for at least one. So it's 1 minus the probability of none. So therefore what we're going to do is we're going to say that our number of successes is going to be 0. P is the probability of success. And a success in this case is considered to be getting a tail. So therefore the probability of getting a tail is a half. So just put in brackets there, tail. And then Q is our probability of failure. So not getting a head is obviously not getting a tail is obviously getting a head, would be considered failure. Okay, so therefore, if I'm looking for the probability of at least one tail, then that's going to be 1 minus the probability of none. Okay, so that's our key in the question. So how do we set this up? Well, the fact that it's at least a 99% chance means that the probability is going to be at least 99%. Okay, so this bit here, the probability of at least one tail is going to be at least 99%. So that means it's not equal to 99%. It's going to have to be set up as an inequality. So therefore, this is going to be, the probability is 99%. Well, 99% is 0.99. Or if you want, you can keep it as a fraction. It doesn't matter. Let's keep it as a fraction, actually. All right, so we'll say that's 99 over 100. Okay. Then it must be less than or equal to 1 minus the probability of none. Well, none is going to be n choose or. So again, let me write the formula up here. So it's n choose or, p to the power of or, q to the power of n minus or. Okay, so our n, we said we don't know. Or we're saying is no successes. P is our probability of success, which is our tail, to the power of or, so that's the power of 0. And then Q is our probability of failure, which is a half, to the power of n minus or, so n minus 0 is just n. So in other words, all of this has to be at least 99%. So in other words, if you're reading that from right to left, at least 99% means it must be greater than or equal to 99%. Okay? So therefore, I need to simplify the right-hand side here. So it's 99 over 100 on the left, less than or equal to 1 minus. Well, what's n choose 0? Well, anything choose 0 is going to be 1. And then a half to the power of 0 is also 1. And then we're left with a half to the power of n. So in other words, we have 99 over 100 is less than or equal to 1 minus a half to the power of n. So we're going to need to try and get this a half to the power of n on its own. So I'm going to bring that to the left-hand side. So that's a half to the power of n less than or equal to, and bring the 99 over 100 to the other side. And therefore this is a half to the power of n less than or equal to 1 over 100. Okay, So now what we need to do is try and get n on its own. So clearly the only way I can get n down here is if I use my log rules. So I'm going to get the log of both sides. So I'm going to get natural log of both sides. And therefore that's going to be natural log of a half to the power of n less than or equal to natural log of 1 over 100. So if I bring down my power, that's n times natural log of a half less than or equal to natural log of 1 over 100. Now, if I divide both sides across there by natural log of a half, I have to be very, very careful, because natural log of a half, if I bring that over here, well, natural log of a half is the same as saying natural log of 1 minus natural log of 2. And natural log of 1 is 0, which leaves me with minus natural log of 2. In other words, natural log of a half is a negative number. Now we know if we multiply or divide by a negative number, then the inequality sign is going to actually change. So therefore we're going to get n is greater than or equal to natural log of 1 over 100 divided by natural log of a half. Or you could write that as natural log of 2 there. Okay, and then if I put that into my calculator, that gives me the fact that n has to be greater than or equal to 6.6. Well, if n has to be greater than or equal to 6.6, n is the number of trials. Right? So therefore, if n is the number of trials, n is always going to be a natural number. So therefore, that means that n must be greater than or equal to 6.6. In other words, n must be equal to 7 to get at least a 99% chance of getting at least one tail. Okay, so if we just go back to the start of the question there, it says how many times must a fair coin be flipped in order that there is at least a 99% chance of getting at least one tail. So in other words, the probability of getting at least one tail is 1 minus the probability of none, and 1 minus the probability of none must be greater than or equal to 99%. So therefore, if you're reading right to left there in that very first equation here, this must be greater than 99%. Okay?